Good morning. Sorry I'm not going to see you today, although this may be for some of the people who didn't see me yesterday. I'm going to try to go over a few of the things that we did in class. I'm not doing this as an ed puzzle, so you can fast forward, you can put me at 2 times speed. But I wanted to go over a couple of things because normally today would have been the seniors' week of healing day. So I had some weird stuff planned that wasn't critical, but it's all useful. So those people who get it are getting more practice and are likely better prepared. At the same time, if you don't get it done, you're not at an extreme disadvantage. I mean, less practice is always something of a disadvantage. Anyway, let's get going. I'm gonna share my screen and share, and hopefully this will all work. Okay, so if you go to the classroom, you will see something in a moment. Actually, I've got it period 1 already. That looks like this. And it kind of shows what we did in class yesterday, which is what we would have done in class today. So that was, yesterday was Thursday, January 6th. Today's Friday, January 7th. And the first thing we did in class, kind of our warm up, was to do this Gapminder preview thing that I assigned the other day, because you should have done it already, but I just wanted to make sure people did it. And I actually told people if they had done it already to just play around with StatKey here. And once again, this is lock5stat.com/StatKey. There's some cool stuff over here. And I just discovered it. I don't know if we'll be using this tool or not, but it was kind of cool because I noticed this graph right here and I was like, oh, there's things in there. And if you actually look at the data, you'll see, oh, this is like how long different animals live. And then there's other data sets over here. Like I can tell toenails and the amount of arsenic, cars, highway gallons, and I can see the different things. So kind of some cool stuff there that you could play around with, but that was not really what we were doing. What we were really doing, once again, going back to the main screen, is we were doing this thing from Monday afternoon or Monday post-class, which I've also put into today's link. So that very first link is what you should have done already. So if you click on it, it'll say you've done it already. If not, and actually I did it yesterday. So you're going to see my answers here. But the idea for this was to go through, again, this thing we did in class. So I just want to kind of reiterate what you should have gotten out of this. So we answered this question, and we got 263 out of 1,000 Americans correctly answered the question. And so that's our best guess for what the actual percentage of Americans who can correctly answer this question is. It's not going to be the exact number, but it's likely to be close to that unless our sample is in some way biased. Like we've only interviewed people who are really well educated or really poorly educated or only live in one section of the country or something. If we've been biased in some way, maybe it's not 0.263 for all Americans. But 1,000 people is a lot. So assuming our methods are pretty good, it's probably pretty close to 0.263. So that was, I think, the first question here was 26.3%. And that's unusual because we'd expect, because it was a 3 question answer, if people randomly guessing, they should get it right. 333 people should get it if we're just randomly guessing. That's what we expect, or something close to 333. So it appears that this seems very low. And very low is relative, but it seems like for 1,000, maybe I might get 330, I might get 300, but 263 seems pretty far away. So maybe something weird's going on. So you were supposed to go back through steps 1 through 9. If I can find it again, I've lost my. Let me slide this down. Okay, you were supposed to go through 1 through 9 of this thing right here. So you went here, and we went in, and we clicked on test for single proportion. And we changed this to edit data, and we said 263 out of 1,000. And the only important thing there is 1,000 because we're setting the sample size. And this just reminds us what our original data was. And then we're comparing this to like, well, if they were actually guessing, they should have gotten 333 out of 1,000. If they were truly just guessing, because that's the odds of 1 out of 3. So, and then we have this thing called Null Hypothesis up there. And we're going to see this a lot. We haven't talked about it much, but basically when somebody makes a claim, that's the Null Hypothesis. Or if we believe something to be true, that's the Null Hypothesis. And we have to gather evidence to say, I think I have enough evidence to show that the null hypothesis is false. Okay, so we're always trying to disprove the null hypothesis. We can never prove it's true. We can only prove it's false, because it's impossible to prove it's true without doing, in this case, without doing a census. Okay, so we're going to generate one sample. So there's what our average is supposed to be. And of those 1,000 peoples that we just simulated, 346 of them guessed correctly. So it's like I've got a giant spinner with A, B, or C equally spaced. I spin the wheel. If I got A, it's correct. If I get B or C, it's false. And I do that 1,000 times, and we write down how many A's versus how many B's and C's. So in that case, 346 people got it right. And if I did another proportion, that did 1,000. So each one of these dots represents 1,000 tries, and then how many they got right. So as many as looks like 380 something out of 1,000 got it right on that particular trial, whereas down here as few as like 0.285, maybe 285 out of 1,000 did it. And if you read the example, it says do it several more times. And so, and one of the questions in there is, what's the shape of this? So we describe this as approximately normal. You could say it's a roughly or approximately symmetric, but if it looks like a bell curve, I would say approximately normal. Don't say it's normal, because we don't know it's normal. In fact, it's not completely normal. And as always, when we're talking about shapes, you're going to have some spikes. So think about if you throw a blanket over this thing, what does it look like? And it looks kind of like a bell curve. It's a little spiky in the middle, but all right. So it's roughly normal. Our mean up here in the corner, very small, is 0.333. For if you've run more than 1,000 samples, it's going to be very close to that. It might be 0.332 or 0.334, but it's going to be very close, because we've run lots and lots of samples. And then I think for most of us, we'll have a standard error of 0.015. This is a standard deviation. Standard error is the name for standard deviation that people sometimes use when they're talking about for a sample, or a sampling distribution is actually what this is called. All right. So 0.015, if I go 0.015 up, that's about right here. If I go 0.015 down, it's about right here. And if I click on the left and right tail, which is what it says to do in the next step, oops, make that work right, it basically goes 2 standard deviations out, or 2 standard errors out. So that was step 6. So it's going to go 2 out. Is that right? Yeah, that's step 6. It's going to go 2 out. So we've got our 95% in the middle, which is 2 standard deviations on either side. That's where 95% of our data. And then we've got one, beyond that is out here. And then it says in step 6, still in step 6, click on this down here at the bottom and change it to 0.263. And that's just going to set where that cutoff is in the lower part. Okay. And so it says 0.263 is way down here. And you'll notice that there are no samples that are this low. If 0.33 is actually what should be happening, because people are randomly guessing, doesn't look like that's ever going to happen, at least in the 3,000 samples that I ran. All right. And then it also says to do the upper one and do 0.403. And 0.403, okay. And that's a little curious, like, why did they do that? And when I asked this in class yesterday, somebody figured out, or I think, that this is essentially the same distance in the other direction. Because sometimes when we test these kind of claims, sometimes we just want to know, could it be as low as 0.263? But other times we want to know, can it be as extreme as 0.263? And as extreme as means, well, just as far away in either direction. It's what's called a two-tail test. And so this is just pointing out that, it's not likely to be that low or likely to be that high. That is a pretty extreme result. If in fact our true proportion of people who can answer this is 0.333, or if people are just randomly guessing. That's really the claim we're testing. All right. So question 8 says, what proportion of dots on the graph have values less than or equal to 0.263 or greater than or equal to 0.403? And there's 0. So in other words, if the proportion of all US adults who would admit to answer the Gapminder question correctly is 0.333, the estimated probability of obtaining a sample result at least as surprising which means in either direction, as 0.263. Notice the p hat there. That's our estimate versus the p without the little hat on it is our proposed population proportion. It's 0. Okay. And notice it says estimated probability too. That may come important later. Okay. Based on the estimated probability in step 8, are you willing to believe the actual population proportion is 0.333? No, which is weird. So something is causing us as Americans, as US adults, to guess worse than random. We are in some way inclined to pick the wrong answers. We're actively picking the wrong answers, which is often actually very hard to do. It is just as hard to get a 0 on a true-false test randomly guessing as it is to get 100 on a true-false test randomly guessing. All right, then they've got this other thing down here, which is a little confusing because it's not related to above, which I actually say in the instructions. Let's go back to my instructions. So we did this. Hopefully you're able to generate the graph and so forth. This is where it asks about how they choose the upper end. They chose the upper end because it was the 0.33 plus the 0.07, which is the distance from those two. And then we're changing it. So another way to kind of test this theory is saying, okay, let's pretend that this is 0.263. Let's say that's actually the correct answer. Let's say we just by chance got to 0.263. We can test it kind of the other way. How unlikely is it that if this is the true thing, that 0.33 could maybe actually show up? So I can just repeat this and you will notice that, you know, things are centered around 0.263. Notice 0.33 is nowhere in sight. I'm going to generate a couple of more. The most I got was 0.31, probably 4 here. If given this, once again, assuming our sampling methods are good, there is almost no chance that 0.333 is the true population proportion based on this sample. Now, this is not technically our null hypothesis. Well, it depends on how you talk about it. But this is a little bit different than people the way have traditionally done it. And the reason people haven't traditionally done it like this is because we didn't have the tools to do it. And people actually thought doing it this way for a long time was mathematically nonsense. And then somebody realized, oh, no, this actually works just as well as doing it the other way. Okay, so then I had several questions about margin of error. So people in that thing, it asked if the actual value of the proportion P is close to 0.263, what is the maximum distance that the sample proportion P hat is likely to be from P due to random sampling variability? In other words, what's the margin of error, which we've not talked about. But they're saying, okay, let's say that we've got 0.263. That's not going to probably be our answer, but our answer should be somewhere in here. You know, it definitely should be between 0.22 and 0.31, I would think. So I don't like margin of error because the thing they never tell you is that this assumes of a 95% level of confidence, which is basically 2 standard deviations in different directions. Margin of error is based off a level of confidence. And in the newspapers, when they do this with polling, it's usually a 95% error, but you can have a 95% level of confidence. You can choose another level of confidence. Like if I did 99%, it would be more. So let me do my left and right tail again. Come on, left tail, left tail, left tail. Why is this not working? I don't know what's going on now. Let me do one more. Maybe I've frozen. Seems like I've frozen. There we go. Okay, I have frozen. Come on, left tail. Come on, right tail. There we go. It was just laggy. I don't know what's going on here. I'm going to come back. But anyway, so this is, there we go. So this is our margin of error. By definition, usually it's the 2 standard deviations on either side. So if 0.263 is our actual, is our estimate, we have a 95% level of confidence that the actual number is somewhere between 236 and 0.291. Doesn't mean it can't be 0.22, doesn't mean it can't be 0.31, but those are unlikely candidates. So we will say, like, if you see a poll in a newspaper and it said 26.3% of people liked this candidate with a plus or minus whatever that distance is, margin of error, then, and they usually do it with percentages. That's just saying, oh, it could be this far above or this far below. So that answer here, our margin of error is 2 times whatever our standard deviation is up here, which I think for everybody is probably 0.014 if you ran enough samples. So it's about 0.28 above or 0.28 below. That's our margin of error. It's the distance from the mean above or below that basically carves out, in most cases, when we talk about margin of error, is at the 95% confidence level, which we'll talk more about. We haven't talked about confidence levels at all. So what values of proportion P are plausible based on the 0.263? So the plausible values are from 0.2636, 0.291. Those are plausible, which means believable. Anything outside of that, it could happen, but it's very unlikely. There's only a 5% chance that a value outside that could happen. And the further you get away, the even less likely that that could happen. I mean, but once again, this could be a really one-in-a-lifetime poll where the 0.263 was way off, and maybe it's actually 0.315 or 0.22 or something like that. Okay, that's probably longer than I spent on this in class. All right, then the other thing you're supposed to do is, you will see, is there are 2 forms. There is one where you are going to be a chimpanzee and you are going to guess randomly. And then there's the other, which is actually the Gapminder questions, and you can see the answers to them when you're done, and you can rate yourself. When we did this in class yesterday, the chimpanzee guess, as chimpanzees, we averaged exactly 4 out of 12, which is what we should if we're randomly guessing. Some people were very good, got 6 out of 12. Some people didn't do so well, they got 2 out of 12, which, it's nonsense. But it shows you that kind of works. So go ahead and try that just for fun. You can see your results and see if you're a good guesser or a bad guesser. And then the second part is, once again, I don't want to show it because I'm thinking my answers might show, is the results for the actual. And I will just say our results from yesterday, there's one that everyone will get that wasn't on the original quiz. So we got to kind of throw one out that everyone will probably get. And there's 2 others you already know the answers to. So when we looked at the results from yesterday, even though we were already biased based on the video, once we subtract out those 3 one that most everyone gets anyway, and the other 2 that we should have known already, we were about 33%, which is great, except we kind of were already been primed to guess a little better than people who hadn't watched the video. So I would do that form number 2, look at your own results. It's kind of cool. And then look at the YouTube video. You can watch the whole thing or jump to minute 5. Minute 5 is where we left off, and just the last 3 minutes explains why are people guessing so badly. It's kind of interesting. And then finally, we went over the AP classroom questions. I'm pretty sure, yes, you've seen the answers to that already, but we've covered it. We covered it a little bit more in depth, and then we did a sample. So let me show you what's in here. And here's what I would suggest you do. I would open the one that says Frappy question. So this is from chapter 5 in our book. Open Frappy question, and it's going to ask you these questions. Most of you are going to probably miss part B. I think I might have. Don't worry about it. Do as much as you can. Set a timer for 15 minutes. That is 12 to 15 is what you should time yourself for free responses. Once you're done, just stop. If you get done early, that's fine. Then what I would do, this is what we did in class. I collected all the papers. Then I would open up these student samples. And what I had people do in class is I actually had them work in pairs and decide, is this the right answer? And is it, let me get off of that. I don't want you to look at that. Is it the right answer? And is it right enough? So if it was really good with lots of explanation, that's an E. If it's so-so, like this seems right, but there's not enough explanation, it's a P. And if it's just like wrong or blank, it's an I. And then have people kind of grade them. And the rule of thumb is got to have all E's to be a 4. If you've got 1 or 2 small mistakes, that's typically a 3. If it's more than that, it's a 2. And then basically, if it's just bad, it's an I. And it's pretty harsh because I think one of these two is not as good. And I didn't think it was a 2, but no, I didn't think it was a 1, but I think it was a 1 because of the way they ranked it. Because I was like, oh, this person kind of knows what they're talking about. But then if you want to, we didn't do this in class, you can read how somebody actually scored those 2 samples. And I'll talk about that a little bit next time because there was a couple of small things I didn't even catch. And then there's the actual rubric if you want to see how that scoring was generated. So once again, do this one first for sure. It's just good practice. It'll take you 15 minutes. Then take a look at some sample answers, decide if they're right or not. There are right answers in there, but they're not identical. And then probably if I was going to do one more thing, you might look at just the commentary because it'll tell you which ones were more right than others and why. And then if you want to look at the rubric, which has the answers and the exact scoring, you could do that. And that's all we did. Okay, I'm going to call it for now. Hopefully we'll see you all Monday. Monday is a B day because next week you don't have school on Friday. So we will pick up something new, but you need, if you don't get this done, it's not going to count against you. It's less practice. There is going to be a grade associated with for people who do it. And it's just an extra grade in the grade book. But I was not expecting to see many of you today because of what was originally planned and other stuff got planned. So hope you have a good and safe Friday and a nice weekend. Let me see, stop share. Bye-bye.